Or what we're going to emphasize here is that we're going to look at more than one equation and see what are the solutions to these things. So if you remember how to graph inequalities, that's 90% of the effort. Okay, so of course, just to review that, we use a dashed line for greater than or less than, and we use a solid line for greater than or equals to, and less than or equals to, and we graph the inequality. So let's say I have y is less than or equal to 2x plus 1. I graph the line. This one's a solid line, of course, because it's less than or equal to. And then I test a point, like if I put in a 0, will I get it? Will I get something that's true? 0 is less than or equal to 0 plus 1, which is true. So when we test that point, we find that this is true, and so if it's true, we shade the side that the point is on. And so in this case, we get something that looks like this. Now, it's possible that you have more than one equation and one inequality, and so that's really what I want to talk to. So I hope you're all solid on this. We had already a section that dealt with this, and I think everybody did pretty well on it. So when we talk about systems then, what we are talking about is that all the equations or all the inequalities have to be true at once. Okay, just like when we're solving these equations with the matrices, what we're looking for is that single point that works in every single equation. Since we have inequalities, we're looking for regions that they're all true. So let me show a couple of examples. Like if we have x plus 2y is greater than 4. Okay, so I graph my lines. You can see how I've done that. You take the, when x equals 0, y equals 2. When y equals 0, x equals 4. And then I test my 0, 0 point. So 0 plus 0 is greater than 4. That's not true, so I shade the other side. So if I take another graph, let's say 2x minus y is less than or equal to 2. This is a completely separate equation. I'll graph that again when x equals 0, y equals negative, should be negative 2. And then when y equals 0, x equals 1. And then we test 0, 0, so that's going to be 0 minus 0 is less than 2. That's true, so we're going to shade this side. Now, if I want both of these to be true, what I do is I'll graph them on the same equation, or on the same axis, I should say, and then I look for the region that they're both true. And so you're actually going to have 4 different regions here. One up here, one here, one here, and one here. And in general, only one of the regions is going to be true. And so, you know, you can take advantage of the fact that your axes are pretty easy to calculate. So if we try, let's say, x equals 0 and y equals 4, that puts it at this particular point up here, we'll find that that particular point satisfies both of these equations. And so we do this little hunt around, unless you already know that if this is above the line and this is to the left of the line, then you know that when those two are overlaid, you get this upper corner. Okay. All right. So let's look at some other regions here. Let's say we have an equation x is greater than or equal to 1. So that's the line that's going to establish that is right here. And then if we take since x is greater than 1, we know this region is going to be on this side. Now notice what I did. I'm not shading. What I'm doing is I'm putting a little arrow on which side is true. Okay, so I know that everything to the right of this is true. Now let's say I have a different equation. Here's one that x is less than 4. So this is going to be a dashed line because it's less than 4. And so the thing that I'm going to do with this dashed line is I'm going to put the little arrows indicating the direction of it as well. So if I just have those two lines, it's the region in between that's going to make the region that's true. But let's say I have some more equations. Let's say I have y is greater than or equal to -3. So I'll plot the line, and then I can test my point, 0, 0, and say, well, is 0 greater than or equal to -3? It is. So I'll put my little arrows, what direction it's going. And then my fourth equation would be y is less than 2. And so I'll put my dashed line indicating it's less than 2, or what y equals 2, and then I'll put my little arrows because I know when y equals 0, that's true. And so you can see I have 4 lines with 4 sets of arrows, and then we can look for where the overlap is. So you can pretty much surmise just based on these arrows. So with this particular one, if you were testing it region by region, you'd have 3, 4, 5, 6. You'd have 9 different places to test if you did it, by region. But on this particular one, since we have our arrows, we know that it's going to be that particular box. Okay. So here's a system. Now, unlike the equalities, where we have 2 equations and 2 unknowns, we can have as many equations as we want because these are inequalities and these things have solutions that are regions, not just a particular line or a particular point of intersection and things of that sort. So let's go through the process here of graphing this. And so I take the first one, and I'm going to say, all right, x minus 2y is 4. So when x is 0, y is -2. And when y is 0, x is 4. And then I'm going to test my point 0, 0. And if I put 0, 0 into the first equation up here, I get 0 minus 0 is less than 4. That's true. So I put my little lines that say I'm above this line. Do the same thing for the next equation. X plus y is less than or equal to 3. So I'll have when x is 0, y equals 3. And when y is 0, x equals 3. Test my point 0, 0 again, and here I have 0 plus 0 is less than 3. That's true, so I put my little arrows saying that it's this side of the line that's true. And then x is greater than 0 is going to be this vertical line here, the axes, the y-axes. And so we'll indicate that it's going to be to the right of the axis since we're looking for numbers that are greater than 0. And so we can shade the whole thing in based on the region that it's true. Okay? Look okay? Shouldn't be too hard. Okay, so here's one for you to try. And we'll try a few of these, and then I'll talk about what the significance of these kinds of equations are. Okay, anybody do this? Anybody finish it? Paige, did you finish it?
I don't think I did it.
Don't think you did?
No, I mean, no, I don't think I did.
Not confident.
No.
Annie, did you do that?
No, I didn't finish.
Didn't finish? You want some more time? Did anybody finish? Emily, did you finish?
Yeah.
You want to do it for? I already drew your axes for you.
Do you want me to explain it like as I'm doing it?
Sure, if you like.
Well, I did the x is greater than 0 and y is greater than 0 first. So when x is greater than 0, it's on the side. When y is greater than 0, it's up. And then for the first one, if x is 0, then y is 4. And then if y is 0, x is 4. And then I tested 0, 0, it's on this side of the line. And then for the second one, if y is 0, x is 8. And then if x is 0, y is 2. And then I tested that for 0, 0, and it was on this side of the line. So it's
Very good. Almost. It doesn't start here, right? This is not part of the
Oh,
solution here.
yeah, I didn't have that shade on my
Yeah.
paper. My bad.
Yeah, and then it continues along the axis here. Okay? Try a couple more. Actually, let me show you on the chart here. And so that's what we get.